Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today I want to talk about how to do a rapid sensitivity study in the Proteus DS Shipmo 3D toolset. I'll explain what I mean by that a little bit, but let's use the stabilizer generic frigate as an example. So this is a good example because we've got a lot of neat appendages on here: bilge, keel, skeg, and of course the fin stabilizers with their own control parameters, etc. And of course, with CKeep random and CKeep regular, you can calculate the ship motion in different sea states and see what's going on. But it may feel a little bit overwhelming, especially when you look at the folder. You've got a lot of different project files in here. Maybe feel a bit overwhelming to try to go and explore some of the different parameters in here and see like what happens. I mean, we've got a lot of appendages here with different bilge keels, static foils for the propeller shaft bracket, and so on. And you want to make changes to these, but there's quite a lot of information in here. You don't want to lose that, and it's a bit painstaking to go through and set up all these details. But there's a way to do this really quickly, and do sensitivity studies to see what happens when you have these with and without them. So the first thing I want to highlight is that all of the applications, build ship, every single one of them has a file name prefix. And if you change this, it's going to make a new file in the project folder with these settings. So let's just say, for the sake of argument, you want to see what happens to the stabilizer generic frigate when we have no appendages on the ship. So this might be a way to sort of gauge the performance of what the appendages are doing, or maybe you would want to do something different, like drastically change the chord or something like that. But this is a common thing to kind of gauge what might happen, is just remove the appendages and then see what happens to the ship. So let's go back to build ship here. We have stab fin gen frig, and maybe I'll call this bare hull. You might want to change the label. You don't have to without appendages. Now when I run build ship, it's going to save a new file in the folder. So we can actually delete all this information to make a really simplified hull. Now, one thing to note here, you can't delete the rudder or the propeller or necessarily the stabilizer fins, because those are project settings, and for safety reasons, to make sure you've got the right model set up, you just have to be careful about what you're doing with that, and you won't necessarily be able to run the ship model. What you could do, though, as a sort of simplification, is just say, well, the span is 0.01, essentially nothing. It won't have much of any kind of area, and there you go. So now when I run this, it's completed. If we plot the ship, you'll see that we have essentially, still have the rudder there, but we've got essentially a bare hull. We don't have the bilge keels, we don't have the skeg. I think there's a tiny little nub there for the stabilizers, but they're so small they won't have an impact on what's happening. Now look in the folder structure here, and we'll see a new file that's been generated. Here we are. Stab fin gen frig bare hull. That's the build ship input file. And then it's also made, now that I've run this, it's made the stab fin gen frig bare hull ship for motion database. Now this is the assembled model of the for calculating ship motions in different sea states. So now what we can do is, so this here is a CKeep random calculation set up for the ship motions in a 3 meter, almost 10-second sea state. Now these results that I've already produced here were with the previous model with the fin stabilizers. So just like in beam conditions, you can see at 0 forward speed, it's got something like 6.7 degrees RMS roll in that condition. So now if I run it again, now if you want to, you could change this, but really what you could just do is quickly, if you go to select ship motion for database file name, now we want to click the bare hull value, click on this, and then run it. Just take a moment. Okay, that's all done. Now we see the RMS roll value. We're at 0 speed here. At beam conditions now 11.2 degrees RMS. So it went quite a bit up from 6.7 to 11.2, and that's really highlighting a very significant change in the RMS roll in beam conditions from all the appendages and of course the fin stabilizer system. So you may be thinking, well, that's great, but didn't I just delete all of my my geometry, all that stuff that I spent so much time putting together? Well, sort of. What you can do is go back to the project settings if you want to get it all back and do the analysis again, or make changes in configurations. Go to the project pane here, go to build ship. Now you can see here it's got the bare hull factor, so don't delete it, but just go to exclude for now. Now you can see it's taken the tab away from here. You go to add existing data. We'll click build ship, and here's our old configuration with all the details. So we can load it back in again, and you can see now we've got build ship. There's the file name prefix, and of course we've got all our bilge keels and everything back again. And again, if you go to CKeep random, just be really careful. You pay very close attention to the ship motion for database file. So I still have this as the bare hull. We'd want to go back to that and click on the original file here with the one with all the appendages. And of course, if we run this again, we'll see, and we go to plot RMS, we're back to the 6.7 degrees roll RMS. So this is a really simple example, but it can be a very powerful way to configure a couple of different and quick way to configure a couple of drastically different ship models, so that we can examine what happens in sensitivity studies without having to reconfigure the ship information each time and delete it and then add it back again. And you can do that for geometry of the appendages or the control settings for the fin stabilizers and different things like that as well. That's all for now. Thanks for watching.